And two, we're going to take strategies that we learned with regards to arc length and circumference, and we're going to apply it to areas of circles and areas of sectors. So the area of a circle, we're going to start with that, is the formula pi r squared. So whatever the radius is, you square it, and then you multiply it by pi. So just make sure that you're not squaring pi as well. R is the radius of the circle, we know that. The sector of a circle is a region bounded by two radii and their intercepted arcs. So notice that you've got radius AB, you have radius BC, and you have this arc length AC. Well, this space in between, this is the sector of the circle, and that has an area to it. So when you're trying to find the area of a sector, by definition, it says the ratio of the area of a sector of a circle to the area of the whole circle is equal to the ratio of the measure of the intercepted arc to 360. So let me kind of relate this to what we did before. Let's pretend, I know this is not exactly a quarter, but let's pretend that this was a 90-degree angle. We know that 90 over 360 is 1/4. So what we know is that this central angle measures 1/4 of the entire 360 degrees of a circle. And what happens is with proportions is now we know that, and we learned in the last section, that this arc length AB is going to be 1/4 of the entire length around the circle or the circumference. It's going to have that same quarter ratio. So the arc length over circumference is going to also be 1/4. So if, for example, the circumference is 8, then the arc length would be 1/4 of that, or 2. And then we learn in this chapter that the area of the whole circle, right, the area of the sector is going to have the same ratio, 1/4, to the entire area of the circle. So yet another proportion. All of these are going to end up being the same ratio of 90 over 360, or 1/4. So let's say the area of the circle is 20, then the area of the sector will be 1/4 of 20, which will be 5. And so you can set it up as proportions. Basically, you need one proportion out of the 3, right, that you have both, the top and the bottom, and then you need one of the other values, and you can solve anything. Or you can just use the formula, which there is a formula for the area of a sector, just like there was a formula for the arc length, right? And it's the area of the sector is basically the ratio of the angle, basically the central angle here, over 360, times the area of the whole circle. And that's going to tell you the area of the piece or the sector. So again, I use proportions, but you can use the formula. We will do examples of both so that you get comfortable with it. So here's some problems. Find the area of a circle with a radius of 4.5. Now this is just a basic area question. It's pi r squared. And if you're telling me, or the problem is telling me, that the radius is 4.5 meters, then this is how I should set it up. What I want to be careful at is what terms do I do it? Do I leave it in terms of pi? Do I use 3.14 for pi? Or do I do it with my calculator, meaning that I actually hit the pi button on the calculator? So here it says, leave the answer in terms of pi and also calculate the area using the calculator. So in terms of pi, I'm going to just multiply or square 4.5. I'm going to get 20.25 pi. So this is my answer, and it's meters squared because area is always the unit squared. That's my area, my answer in terms of pi. Now, if I was to do it using my calculator, I'm actually going to multiply the 20.25 by the pi on my calculator, and I'm going to get an approximate answer for my area of 63.6 meters squared. And so that's a valid answer. It didn't tell me what to round to, so I just did tenths. And so again, it's approximate because once I used pi In my calculator, this was a rounded answer, which is not exact. Next question, find the radius of a circle with an area of 176.7 square feet. So again, area equals pi r squared. The area, 176.7 equals pi times r squared. And I'm going to have to isolate r, right? Because I need to know the radius. So first I'm going to divide by pi, and I'm going to get r squared equals 176.7 divided by pi. And again, since I'm looking for r, it's going to be the square root of these numbers, right? So r is going to be equal to the square root of whatever this equals. So I go to my calculator, I do 176.7 divided by pi. I'm going to get that answer, and then I'm going to take the square root of that answer. And so my radius is going to be approximately equal to 7.5 feet. So again, you just do the math and you square root the r squared to get r isolated. I could factor out. Again, here they're asking me, they're telling me that the radius of a circle is 3 centimeters. And they want me to find the areas of the sectors determined by the given arcs. They want my final answer in terms of pi. So first of all, let's picture this, right? We have a circle, we've got a radius of 3. So the first thing I know I'm going to have to do to find the area of a particular sector is I'm going to need to know the area of my circle. So the area is pi r squared, which means 3 squared times pi, or 9 pi. So I know my area is 9 pi. It's kind of a big deal. In A, my angle is 50 degrees. So my angle is 50 here, right? Here's my radius. And so if my angle is 50 degrees, well, how do I do this? Well, if I use ratios, I'm going to do 50 over 360 is equal to the area of the sector, I'm going to make it x, over the area of the whole circle, 9 pi. And I'm going to do proportional math. So 360 times x equals 9 pi times 50. 360 times x equals 450 pi. And if I divide both sides by 360, I'm going to get my final answer. Now, because I can leave my answer in pi, I'm only going to divide the 450 by the 360. Okay, so I could do 450 divided by 360, and I'm going to get 1.25 pi. That's a valid answer, and it's going to be centimeters squared. Okay, the other thing I could do is I could just simplify this fraction. I know that 90 goes into both of these, and it's 5 pi over 4 would be simplified. So that could also be the area of the sector. So I could do either one of those two things. Okay. Something that could have made my life a little easier is I could have simplified 50 over 360 and made it 5 over 36, and that would have made the math a little simpler, but it would have given me the same final answer. And again, if I'm wanting to use the formula, I know the area of the sector is going to equal, again, the ratio of the central angle over 360, right, or the arc degree, times 9 pi, which is the area. So again, if you do it this way, notice it's going to be 50 times 9 pi all over 360, which gives me the same 450 pi over 360, which is going to give me the same 5 pi over 4 centimeters squared, or 1.25 centimeters squared. So I'm going to set them up both ways for you, just to, because again, I don't know what method each of you is going to prefer. When I go to the second problem, I get 20 degrees. So once again, I can solve it as a proportion. I know 20 over 360 is going to equal x over 9 pi. And I know that 20 over 360 simplifies to 1 over 18. So I'm going to do that. So I'm going to get 18x equals 9 pi. And when I divide by 18, I'm going to get that x equals pi over 2 centimeters squared. So that's the area of my section. And I'm going to leave it with pi like that. I'm not going to do anything else. Then if I do it with the formula method, it's going to be, again, the area of the sector is going to equal 20 over 360 times 9 pi. And again, I'll get 180 pi over 360, which simplifies to pi over 2 centimeters squared. So again, the area formula is completely acceptable. It's just whichever you prefer. When I get to the 140 degrees, again, it's 140 over 360 is going to equal x over 9 pi. I'm going to simplify this a little bit, right? And 2 goes into these as well, so I got 7 over 18. So I get 63 pi equals 18x. And if I divide both sides by 18, I'm going to get x equals 63 pi over 18. And since both are divisible by 9, I'll do 7 pi over 2. And that's my answer that way. And this last one I'll do using the formula. So again, I know the area of the sector. Oh, and this is centimeters squared, sorry. The area of the sector is equal to the degree over 360 times 9 pi, the area of the whole thing. So again, I can simplify this a little bit, right? I can make it 21 over 36 times 9 pi. I can even go, I could factor out a 3 here and make it 7 over 12 times 9 pi. That's going to equal 63 pi over 12. And again, I can take a 3 out of this as well. So this could be 21 pi over 4. So if I keep simplifying, I can get it down to that answer, which is the most simplified version of the answer. So whether you choose to use the ratios I showed you or you choose to use the formulas, whether it's in arc length and circumference or arc sector or sector area and area, that's up to you. Last question. Find the area of the region bounded by segment AB and arc AB. Leave answer in terms of pi. So what they're wanting actually is the area. Segment AB is here, okay? And arc AB is this. So what they're actually wanting me to find is this area in there, okay? That little gray area. So what I notice is that this is like going to be kind of like a composite shape. I'm going to have to find the area of the entire sector, right? If I find the area of this whole sector and I subtract out this triangle here, that's going to leave me with this. So I'm going to have to do a couple area problems here. I'm going to have to utilize a couple strategies here. So first, let's find the area of the entire circle and the area of this sector. Let's start with that. So area of circle is going to be here. We've got a radius of 6, so it's going to be pi r squared. It's going to be 6 squared times pi, or 36 pi. So I know the area of the circle is 36 pi, whatever units squared, right? The area of the sector, let's go there, right, is going to equal the ratio of the central angle, 120 over 360, times the area of the entire circle, which is 36 pi. So I'm going to simplify the 120 over 360, and I'm going to make that 1/3 times 36 pi. That's going to give me 36 pi over 3, which simplifies to 12 pi. So I know the area of the sector is 12 pi. And notice it says I can leave it in terms of pi, so I'm not going to have to go any further from that. So now what I'm going to have to figure out is what is the area of this triangle. Now finding the area of the triangle is a little tricky because this isn't in this section. This is from previous sections. But if you notice, you see that the central angle is 120, and you notice that this is an isosceles triangle, which means angle A and B are equal. So if this is 120, the triangle's angles add up to 180, so there's 60 more. That means this is 30 and this is 30. And to do a triangle, I need to have an altitude that's at 90 degrees. So basically, I'm bisecting this angle. And notice that I'm turning this into a 30, 60, 90 triangle. And with a 30, 60, 90, I'm able to find my missing sides. Remember, 30, 60, 90 have sides of A radical 3, and 2A. Notice the side opposite the 90 is 6. That means that A has to be 3. So the side opposite the 30, which is this height right here, is 3. And the side opposite the 60 is 3 radical 3. So that's this half right here. So if I add 3 radical 3 plus 3 radical 3, I'm able to get the base of this triangle, which would be 6 radical 3. So now I have the base and I have the height of 3. Now I can find the area of the triangle. So the area of the triangle is half base times height. And in this case, the base is 6 radical 3 and the height is 3. So when I do the math here, right, I'm going to get 3 times 3 is 9 radical 3. So the area of the triangle is 9 radical 3. So now that I know the 3 areas, the whole circle, that helped me find the sector, and I found the triangle. So now I have what I need. The shaded area, this is the area that we were looking for. This area here, that's going to be the sector area, right, minus the triangle area. That makes sense, right? That's going to leave you that little piece. So the sector area is 12 pi, and the triangle area is 9 pi radical 3. So we could answer this as 12 pi minus 9 radical 3 inches squared. Because they told us to leave it in terms of pi, we don't have to, we'll call it the shaded area or whatever, the shaded area. We don't have to do it any more than this. If we wanted to be more specific, we would actually just multiply 12 by pi and subtract 9 radical 3 from it and get our final answer. But that's how you do it.